So here we are targeting question A, part 2. So A part 2 is saying, can we find if the universal set is from -1 to 8, and you're given A to be 5 to 8, B 2 to 6, and C 4 to 7. Find A complement intersection B and B intersection C. So you get the union of those two. So let's start with B intersection C. So what is B intersection C? So if we check lines, the universal set is up to 8. So here's the difference. If the universal set is finite, if it's a small set, not R. So when drawing the universal, I draw the universal itself. I don't draw from -infinity to +infinity. No. I draw from the boundaries of what? The universal set. So you do from -1 to 8. And then now we bring in set B. Set B is from 2 to 6. 2 included, 6 included. Like this. Then C from 4 to 7. 4 not included, 7 not included. Then get the intersection. So we get the common piece. So intersection is from 4 to 6. 6 is included, 4 is not. So you look at where you are picking the numbers. 4 is coming from set B, where it is closed. I mean, 4 is coming from set C, where it's open. So we also open. 6 is coming from set B, where it's closed. So it will be closed here also. Because in the other set, the line is passing through. So meaning it's closed. So now we also need to get A complement intersection B. So we'll draw another line. So let's draw the lines. Up 8, open at -1. And what do you want? We want A complement. So what is A? A is from 5 to 8. Now, 8 is open. A is open at 8. So when you look for A complement, we put a closed dot here. Because there's no 8 in A. And yet there is 8 in the universal set. So we put a closed dot there. From there, we go to 5. 5 is closed in A. So we open and go where there is no A. The universal we don't change. If you find it open, you open. So what I've plotted there is only A complement. So that I bring B. B is from 2 to 6. So closed, closed. So this is B. Okay. What do you want? The intersection again. So we take the intersection from 2 to 5. So A complement intersection B is equal to 2 to 5. Five not included, 2 included. And the question is saying, find the union of those two. So if we draw another number line, now trying to pick the union. So let me draw it from here. So this is 8. That is minus. Excuse, that's -1. So from 2 to 5, from 2 to 5, open, close. From 4 to 6, open, closed. Union is everything in here plus everything in there. So the union of these two are A complement intersection B, union B intersection C is equal to 2 to 6. So that's how you finally get the union. So you pick when you have such sets. Well, there's no harm in choosing to expand, simplify, if you're good at that. But sometimes you find that you can do the expansion as much as you want. You still find that you have different sets that you must combine separately before you can come to combine it in the final solution. So sometimes it doesn't help you simplify. Okay. So let's pick part A when we are still here. Part A says, given that A and B are non-empty sets, simplify A intersection B minus A. Just to simplify it. And you get 2 months. Okay. This one was saying after you find the answer, you should also present on the number line. So let's do that. 8. That's 1. The answer is 2 to 6. Close. Close. Wow. So it's possible you could simplify. Yeah, you could simplify. And get the answer to be B. Then you just don't solve. Okay. But let's go back up there and simplify. So we have A intersection B intersection A complement. So to get rid of the minus, intersection complement. So now we have A. So when there's intersection, you are free to even remove the brackets. So in this case, we can write this as A intersection A complement intersection B. We can even open up because of the same operation, intersection. But A intersection A complement is empty. Intersection B, which makes everything empty now. So the fact that they say, given that A and B are non-empty, simplify, it doesn't mean that we cannot find an empty set as a solution. We can find it. Okay, so that part, we've tackled it now from the end of test one for last year and from the end of test one for this year. Now let's go back to test one for last year and pick the questions that followed. Then we'll come back and finish up this question one here because of the combination of things. So now we're here. So let Z1, Z2, and Z3 be given. Express the following complex numbers in the form A plus IB. Okay, the first one is Z2 minus Z3. So what we do is we first go to Z3. We first go to Z3. And write Z3 in this form. So we conjugate Z3. It will be 3 plus I and also add 3 plus I. So we get 2 times 3, that's 6. 2 times I, and that's plus 2I.
So,
Hello,
which question are we solving here?
this one.
Which one?
Okay, that's question 1.
Then 1B.
Okay. I mean, is it BI or B2?
It's BI.
Well, we are trying to come to BI, but before we come to BI, we are conjugating Z3. Since
All right,
it's the only fraction that we have there, so we choose to work it out and then see how it will be.
Oh, all right, thank you.
Okay. And then, so we are on 2 by I. So now we come to 3 by I. And I by I will be minus 1. So we divide by 3 by 3, 9. And I by I minus 1. Times this minus that is here. So we get plus 1. We are going to have 6 minus 1, which is 5, plus 5I over 10. So that what we get now is 1 plus I over 2. So that when we come to Z2 minus, when we come to Z2 minus Z3, it would be Z2 is minus 3 plus 7i minus Z3. So we can now split it and write it as half plus I over 2. Which you can now expand and say, okay, so we have minus 3 minus half plus 7i minus I over 2. So minus 3 minus I, that would be minus 7 over 2. And then and then 7i minus I over 2. So that's 14 minus 1. So we're going to have plus 13 I over 2. Okay, let's explain things here. So here we had 5 plus 5, and then there's 10 down. So 2, so 5 can go in itself once, and in 10 twice. That's why it has reduced to that kind. And then now, when you pick the Z2, you pick Z2 the way it is there, minus 3 plus 7i. And then pick Z3 in the simplified form there. So you can split the form so that it becomes a bit easy for us to see that, oh, we're dealing with 1 over 2 plus I over 2. And then you put the real parts together and the complex parts together. Hello.
It's on the part where you say 1 plus I over 2. So it's all right if we just do a cross multiply where it becomes negative 6 plus 14i. Then we drop the separate.
Yeah, for as long as the 2 is down there, it doesn't go anywhere. Okay.
Hello.
Hello.
Yes, sir. I wanted to ask, when finding the conjugate, do you always like only use the denominator? You can't use the numerator to find the conjugate.
You always use the denominator.
Okay, thank you, sir.
Sir,
Hello.
I wanted to ask on the second part for negative 3 plus 7i. How are you doing it? How are you multiplying negative 3 by half and then you do plus? Shanshan, kindly explain.
Negative 3 plus half. So here we picked this minus 3 and this minus half. Those that don't have i's. And then we got the common denominator here. So we say 2 down, 1 into 2 by negative 3, 2 into itself by negative 1, and then plus, again 2 down, there's over 1 there, So we have 14i minus I, like that. Is it okay?
Yes, sir. Thank you.
Good. Okay, so now we want to move to part 3, Z2 divided by Z3 minus Z1. So let's start with Z3 minus Z1. Z3, we have found Z3 as 1 over 2 plus I over 2 minus Z1. Z1 is minus 2I. That's Z1. So when we do the subtraction, half remains because there's no real part on the other number. So we just put together these two, I over 2, negative, negative becomes plus 2I over 1. So we get half, and then plus 2 down. Then we have 2 in itself, that's 1. 1 times I, that's I. Plus 1 into 2, that's 2. 2 by 2, we get 4. So we get 4I. So that we get half plus 5I over 2. So that part we have gotten is just a Z3 minus Z1. Now, because we are taking it in the denominator, let's work it out better. We write it as 2 down and then 1 plus 5I up. This is the common denominator. We have 2, so nothing will change. Then now we go to part 3, to part 2, and pick whatever is there now. Z2 is minus 3 plus 7I. So we're dividing this by 1 plus 5I over 2. That is 2 times minus 3 plus 7I over 1 plus 5I. Like that. Okay, so you expand now here, so it will be minus 6 plus 14I over 1 plus 5I. So we still have a job of rationalizing that number. So let's get it here, minus 6 plus 14I. We multiply by the conjugate of the denominator, 1 minus 5I. 1 plus 5I, we multiply by 1 minus 5I. That is minus 6 plus 30i plus 14i plus 14 times 5. So I've said plus because I times I is negative. And then we have another negative. That is with negative with 5 there. So 14 times 5, yes. So that is 70. So we have plus 70. Then to divide, we just divide by 1 plus 25. We'll just multiply 5 times 5, we get 25. Then I times I is -1 times a negative on 5. Next positive. So now we have -6 plus 70. And that's positive 64 over 26. 30i plus 14i. That's plus 44i over 26. We can divide things. I think 2 can go in 64, 32 times. And 2 into 26, 13 times. Plus 22 times. 13 times. That is the answer question. Any questions? Silence means doing now. Okay. I'll see you there. Okay, all right. Let's see. Okay. So now we want to do the third one. It's a bit tricky, this one. Since it comes as a root. So you first we assign a variable. We say z will be equal to the root of z1, but z1 is -2i. Don't worry, in complex numbers, we also have roots of negative, so that's not a big deal. Okay, so we square, before you square, you can first assume that your z is x plus iy. And then you come back now, where there is z there, you put x plus iy equal to the root of minus 2i. Then we square this side, we also square this side. So that we get x squared plus 2x yi, then minus y squared equal to minus 2i.
Where have we equated x z to x plus iy?
So z is a complex number. Since we must express our answer in the form a plus bi, I can choose any, provided they will separate in the form a plus bi. So it's too well to go straight and use an a plus bi. Oh, okay. So then the x squared plus 2xyi minus y squared comes from the expansion of x plus iy. So now we get the 2xyi and equate it to the minus 2i. The i's equated to each other. So when we divide by 2i, we have xy equal to minus 1. Because the i's will cancel and the 2's will cancel, remaining 1/1. So we can divide one of them. Let's divide by x. Let's divide by x. So what we are saying here is that y is actually equal to minus 1/x at the moment. And then if we went back to x squared minus y squared, it will be equal to 0 because there's no real part the other side. Okay, there's no real part the other side. So because there's no real part the other side, we equate x squared minus y squared to 0. Now the y part, we have solved it in terms of x and has come out to be 1 minus x. So we come here and where there is y, we put minus 1/x. Then we square it equal to 0. Meaning we now have x squared minus 1/x squared is equal to 0. If we multiply throughout by x squared, we are going to have x power 4 minus 1 is equal to 0. Like that. Okay, time 1 that out for this one. Maybe that's where I will start from tomorrow. And it was a deep complex question, so you can't squeeze it. So we'll do this one and then we'll do the one that is in test 1 for this year. So you can start because they have a similar concept. They all have the root 3.